Hey, GAT Math students, this is notes for Intro to Geometry, objectives 12 through 15. So if you don't have your packet out, hit pause, go grab your packet. Also, reminders, we go anytime if things are going too fast or you didn't hear something. Remember, you're watching a video, you can hit pause, rewind, rewatch it, go back so you can get everything written down that you need to have written down. So you should be open to this page here. There's 4 objectives. This may be the easiest section that we've done so far in this for the Intro to Geometry. It's going to be pretty straightforward, knowing some formulas and being able to apply those formulas. So, which is, maybe you're not going to use a lot of area formulas and whatever your future job is, but basically in any job, you're going to be given directions and you have to be able to apply those directions no matter what the job is. So that's partly the lesson here. Obviously, partially the lesson is being able to figure out areas or shapes, but also to be able to be taught something and then be able to apply that, which is something you're going to have to do in any job. So to start, we don't have as many problems to do as we have in some of the other sessions, but we are going to do a few notes first, just so we have the formulas, and then we'll go do some problems. So what I'm going to do here, let me draw a line here first, and then I'll go back. See if I can draw the, whoops. All right, so these are all going to be area formulas. Okay, and the first type we're going to look at the rectangle. Okay, probably the easiest one. You have your width and you have a length, and the area is just length times width. And we'll do examples here in a little bit, so on how to apply these. I just wanted to have the formulas written down. So that's the first one. Next one's very similar, but there's actually 2 ways to go about this. A square, you can do the exact same as a rectangle. So square is just a special rectangle. So you could still just say length times width, or for a square, they can just label one of the sides with an S and just say the area is S squared, which means S times S. So either one of those would work because the square is a special case where all the sides are the same. So you take S times S and give you S squared. Okay. Next one, triangle. Okay, there's 2 versions here that we're going to look at. Area equals 1/2 B times H, or you can say B times H divided by 2, as those 2 are the same thing. And this is where B is what they call the base, and H, which is almost always in math, the height. Okay. All right, so that's what they're called. So now let's look at how we use these. The other thing we need to know here, this is important. I'll draw a picture here in a second. The base and the height. Again, if this is hard to read, open it in a bigger window, go full screen, rewind, listen. I know I don't have the best handwriting. But it says here, the base and the height form a right angle. That's important. So let me show you what I mean. So the one, I'll show you two pictures here. One that's pretty basic and one that can be a little different looking. So if we have this, and any side can be the base, it will just, the numbers will be different and the drawing will look different. But if this is the base, the height is not part of the triangle. So do a dotted line here, down, this length would be the height. Okay, sometimes it can look like it's not even part of the triangle or inside the triangle. We had a long kind of triangle like this, and if this was, we said was the base, it's hard because we can't draw the height has to go from a point to the base. Okay, so it has to be either start here, here, or here, and to draw it down to the base, we have to actually draw an imaginary line. So if we use that for the base, here's your right angle, and this is the height. So again, we'll look at some examples that'll make that a little more sense. Okay, but the height h goes from a point to the base, even if it's imaginary extenuating lines. Two more. Next one is actually a pretty easy one. Parallelogram is basically the same as a rectangle, except they don't use length times height. They call it base times height. And so if we have a parallelogram, remember a parallelogram is a shape with two sets of parallel lines. So this line and this line are parallel, this line and this line are parallel. And if you pick whatever side is the base, the height is a perpendicular line connecting the opposite side of the base, which is the same length. So that would be the height. Okay. So the height is between the base and the opposite side, which is the same length. And forms a right angle. Okay. So that's a parallelogram. And then the last one, again, I know that's hard to read there. Rewind it, listen to the words, get it written down. Last one is a trapezoid. Trapezoid is similar to a parallelogram, except a parallelogram has two sets of parallel sides. A trapezoid has just one set of parallel sides, so it may look like something like this. So this side and this side are parallel. We need two sides, or we need the lengths of the parallel sides, and we'll call those A and B, and then the height is going to connect those. So the formula can be 1 of 2, 1/2, and then in parentheses times A plus B, and then times H. And the same thing there would be, you can do A plus B over 2, all times h. Those are both the same thing because multiplying by half or dividing by 2 is the same thing. Okay, so now, A and B are the lengths of the parallel sides. And H connects them at a right angle. Okay. All right. So those are our notes. So now, once we know those and can refer to those, the problems that we're going to do aren't really that difficult. Okay. So I'm going to kind of skip around because I'm going to go in order of kind of the shapes that we're looking at. So I'm going to start with 68. Now this one is a rectangle, so the math of doing it is going to be easy. But the way they don't just tell you, if they just said the length was 2 and the width was 4, it'd be easy. It'd be 2 times 4 is 8. Then you have to find it. And this picture doesn't need to be perfect, but they give you coordinates. So we're going to go and find -2, -8. So 1, 2, 3, 4, 5, 6, 7, 8. It's not going to be perfect, but there's 1 point. -2, 4. So -2, and then 1, 2, 3, 4. Again, this doesn't have to be drawn perfect because we'll look at how we're going to label this in a second. C is 8, 4. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, and then up to 4. And then D is 8, -8. So this was out to 8. This was down to -8. So here's our rectangle. Okay, so now we just got to label the length and the width here. So this one was -2, -8. So that was 8 down and -2, 4, 4 up. So this was 8 down, this was 4 up. So that width from here to here is 12. Okay, so if we're saying area equals length times width, we'll fill that in a second. Then here, again, was -2, so this was 2 over, 2 to the left. Distance-wise, you don't have to write negative, it's just 2. And they went 8, 4 here, so this was 8. So this whole distance from here to here is 10. So area equals length times width. Length is 10. Width is 12. We get 120. Okay. So that's a rectangle problem. I think there's one more rectangle problem like that, and then I think the rest of the rectangle problems are actually easier. They'll either have a picture or they'll just tell you this is the length, this is the width, it's a rectangle, and just multiply. Okay. 67, parallelogram. Make sure we have what we need. Parallelogram, we need a base and then the height between the base and its opposite. So we have a base and the height here at a right angle. That's all we need. The area is just base times height then. So area here, 9.7 times, remember, next to each other in parentheses just means multiply. So multiply those and you get 77.6. Okay. So I'm going to go We're gonna skip around a little bit. We're gonna find the other parallelogram problems. We're gonna go all the way to 86. Just catching up here. It's gonna be quicker for you, just turn the pages, but we're gonna go. Okay, and the reason I did, so again, same formula here, it's parallelogram, area equals base times height. Now the only reason I chose this one to do is because they show you three numbers here. And you just have to figure out what you need to use. Now this is the height. Okay, so we're gonna use 57 for sure. Okay. Now the height connects the base to its opposite side. So here to here. So we're not going to use that. If we had a line drawn, dotted line here with a right angle drawn in, then we'd use this side and not this side, but it's connecting these two. And so then we're going to use 71 for the base. So we're just going to have 71 times the height of 57. And once you figure out what numbers to use, it's that simple. Okay, so those are parallelograms. There's a couple other examples in there for that. We're going to go all the way back to number 70. We're going to look at just two triangle problems. We only have 4 problems to go. All right, so number 70. Again, they give us a bunch of numbers here. We're not going to need them all. Okay, I'm going to use 1/2 base times height. Remember, you can also go base times height divided by 2. Same thing. So remember, we have a height, and that connects the base at a right angle to a point on the opposite side. So it's connecting at the right angle. That means this is our base, and not here, and not here. Okay, so you just have to choose the right numbers. So I'd have 1/2 times the base of 32 times the base of 8. Okay. So you could change that if you wanted to. I could have done this before, but remember 1/2 is 0.5. Okay, 0.5 times 32 would be 16 times 8 would give you 128. Okay, again, you could have use this one too. I'm not going to do this on the next problem, but if you wanted to do it this way, it would be 32 times 8 divided by 2. And that would be 256 divided by 2 equals 128. Okay, so either way, you can get the same answer there. Okay, now we're going to go to, sorry if we keep doing this, but we're going to go to 84. Do the next type of triangle problem. Again, it's not much different here, but just to show you that sometimes the height is not in the triangle. So this is one of those instances where the point across from the base that we're going to use isn't actually at a right angle above it. So we have to use an imaginary line until we get to a right angle to that opposite point. But otherwise, it's going to be the same thing. We just use this. I'm going to change that to 0.5. Base is 3.2. Height is 9. Take my calculator, multiply all those, you get 14.4. Okay, and all these are areas, and you don't have to worry about this with multiple choice, but centimeters squared would be, or squared centimeters, either way. You don't have to worry about that with the multiple choice so much, but just so you know. And then 2 more to end with. We're going to look at trapezoid problems. So we're going to go to 87. Okay. So again, if you look back at that first page and we did our formulas, a trapezoid, first of all, has 1 pair of parallel lines. So it's not this, the A equals B times H. This is the A equals 1/2. And then parentheses, A plus B, and then times our H. Okay, so A and B are the lengths of the parallel sides. So this is parallel to this. The H is the distance between them at a right angle. So this is the number we don't need. Okay, so we have, actually, let's convert that to 0.5 for 1/2. Then we're going to have 26 plus 40. And then also times the H, which is 7. So 0.5 times 66 times something. Now you could just use your calculator, obviously, at this point. Or you could take another step. This times this is 33 times 7. That all equals 231. Okay. All right, one more problem. It's probably one of the most involved problems, but still not too hard. We're going to go back to 76. Okay. So there's one other problem like this, so you'll be able to look at this, do a practice one like this. So it looks like an awkward shape. This is not, the way it's given to us is not one of the shapes we have in the formulas that we got, but there's two separate shapes here. Okay, we have two trapezoids. So this is parallel to this, and then this is also parallel to this. Okay, so if I redrew these, they're not going to be perfect. This is the first one with a 5 there. We need the opposite. So this would be like our side A. Opposite of that, the parallel. Let's pretend that's parallel. That's 22. Okay. And then the height between the two is given right here. And it's already at a right angle, so that's the height. Then we have the other side. Again, this is at a right angle. This is 22 because it's shared with here. This was 13. And again, the height between them, here's 10. So what we're going to do, we're just going to do this twice, but we're using this formula. Okay, so this first one, which is over here, we're going to take area equals 0.5. The two bases are A and B, 5 plus 22. And then we have the 16 as the height. Okay, so that's the first trapezoid. Second trapezoid, we get, again, 0.5. We have the 22 plus the 13. That's the A and the B, the parallel sides. The height is 10. So now we go 0.5. This is 27 times 16. Multiply all those together, and you're going to get 216. So that's the area of just this side. Over here, 0.5. This is 35 when you add those together. Then times 10. So multiply all those, get 175. And then the key here is that you want the area of the whole shape, so you have to just add those together. And you get 391. Okay. So that is all the problems we need to do. I think the rest of those you'll be able to do. The last thing I'll just do for you here is summarize. End here. Let's show you which ones we did. Did 68, did 67, did 86, did 70, did 84, did 76, we did 87. So again, the reason I circle those is because not only is this just the key back here, but if you're trying to do like number 82 and you not sure how to do it, you're not getting an A for an answer. Well, this is in objective 13. Well, we did two other problems in objective 13. We did 67, we did 86. So 82 is going to be like one of those two problems. So you take a look at those and look at the example and then try to do it. If at that point you can't do it, then that's when you need to contact me and ask a question. So that is notes for 12 through 15. If you do have any questions, let me know.